Hi guys, this is Mrs. Foy, and this is a screencast about how to calculate the excess reactant and how much excess reactant is produced. So if you're watching this screencast, you probably are in my class and you already know how to calculate the limiting reactant. If you do not know how to do that, you probably should watch that screencast on limiting reactants. But this one is kind of going a step further to find out how much of the excess reactant is produced. So let's get started. Here is a reaction. Photosynthesis uses carbon dioxide and water to produce glucose and oxygen gas. So the problem is, if you reacted 88 grams of carbon dioxide and 64 grams of water, what is the mass of glucose produced? What is the limiting reactant? Now, that actually has to be calculated to figure out how much glucose will be produced. What's new is this thing that we call the excess reactant, and then the question says how many grams of excess reactant are left over. So the first thing we're going to do is just a regular limiting reactant problem. So you guys have seen this before. I start with a balanced equation, right? These coefficients are going to be important because they're going to be the mole ratios that I need. And I draw these little boxes to show my students what the mole ratios are. So I'm going to be comparing how much of the glucose I can make with my carbon dioxide. And then in another problem, I'm going to look at, if I had 64 grams of water, how much glucose am I going to make? Here are the molar masses for you, just makes it a lot easier. And now we're going to do our limiting reactant problem. So this is a double problem, right? We have to start with our carbon dioxide, and here we are converting to moles. And then this step right here is our mole ratio step. That's moles of CO2, 6 moles of CO2 for every 1 mole of glucose. And then 1 mole of glucose is the molar mass right here, 180.16 grams in 1 mole of glucose. And I get 60 grams of glucose. Now, I don't know that's a limiting reactant yet until I do my green problem here. So I have to do the same thing with water. So I start out with my mass of water. Here I am converting to moles of water. This is my mole ratio step, but again, this is a little bit different. It's 1 to 6, but it's 1 mole of glucose for every 6 moles of H2O. Sorry, this should be H2O. And then my moles of glucose cancel and I get my grams. And so when I compare 106.64 grams of glucose with 60.04 grams of glucose, this is the lesser amount. Therefore, that means that my limiting reactant is carbon dioxide, and I am going to produce this much. So that means my excess reactant is water. So now I have to do an additional step because the problem asks me how much water is going to be left over. Remember, I'm starting with 64 grams of water to start. So this is what we do next. So again, I am looking at my balanced equation, and guys, basically this is a third Stoick problem that you have to do. So here's how you do this. I know I am going to make 60.04 grams of glucose because remember, I am going to run out of my carbon dioxide, okay? But now I want to know how much of the water am I actually going to use up. I need to know how much water I'm going to use before I can figure out how much is left over. So I'm going to do a final Stoick problem. This time I'm going to be comparing the glucose that I've made to water. So I have 60.04 grams of glucose, and I use the molar mass of glucose to convert to moles. I'll always get to moles. And then here's my molar mass. Here's my mole ratio. This is my mole ratio. And notice that it is a 1 to 6 ratio, and I put 1 mole of glucose on the bottom so my moles of glucose cancel. My 6 moles of water on the top, and then I'm converting to grams, and I get 36.03 grams of water used. In order to make this 60 grams of glucose, I'm using up this much water. So I had 64 grams of water to start. That was the information given to me at the beginning of the problem. I just calculated in this third Stoick problem that I am going to use up 36.03 grams of water. And so with simple subtraction, I find out that I'm going to have 27 grams, 27.97 grams of water left over. So here's a reaction for you to try. In the reaction between solid sodium, so solid sodium, and iron 3 oxide, so I've got iron 3 and then oxide I know is -2, iron metal is produced along with some sodium oxide solid. Sodium oxide solid. If I have 100 grams of sodium and 100 grams of iron 3 oxide, what is the mass of solid iron produced, and what is the excess reactant left over? So my reaction is going to look like this, right? I have to write down my reaction. And then I'm going to have to balance my equation to get my coefficients so that I know what my mole ratios are going to be. So in this problem, I'm going to find out, and this is not balanced yet, right? So you have to balance the equation, but I'm just showing you the mole ratio. So I know I'm going to do a mole ratio here, and then I'm also going to do another mole ratio here, and then I'm going to figure out which of those is least, but I got to balance my equation first. Good, so here's my balanced equation, and I'm going to have you guys try this. I want you to pause the video and see if you can find out what is the limiting reactant, which you should be able to do. So you are going to do one problem where you're going to calculate how much of the sodium is going to be used up to make the iron, and then you're going to find out how much of the iron 3 oxide you're going to use, and whichever one is least, that's going to be your limiting reactant. That means that the other reactant is going to be your excess. So I want you to do that problem first. Pause the video and do that first. Okay, so once you have done that problem, you found out how much iron you're going to be making. And so the last step to find out how much of the excess is that you need to do another Stoick problem to find out if you produce how many grams of iron you're going to produce. And then you're going to convert that into moles of iron. And then you're going to do a mole ratio between the moles of iron and the moles of your excess reactant, whichever one was not the limiting. And of course, this ratio comes from the balanced equation. And then what you're going to do is you're going to take 1 mole of that excess reactant and you calculate the molar mass, and you're going to get grams. This is going to be grams that are used. So that's going to give you the mass of the grams of the excess reactant that are used. So then you take 100 grams to start minus what you just calculated, and that should be the excess reactant. So pause the video and do that final step, and let's see if you get it right. Did you get it right? So you should have gotten that 69.92 grams of iron is produced, and that your iron 3 oxide was a limiting factor. That means the sodium is the excess factor, the excess reactant. So you needed to calculate how much of that you would actually use and subtract it from the 100 grams that you had. This is what you calculated, right? And then you should have gotten 13.6 grams of sodium left over. Okay. Okay, so I just wanted to show you another, there's several different ways that you can actually do this. I just wanted to show you another problem. So here's my balanced reaction, all right? And obviously I've got 90 grams of my iron 3 chloride, and I've got 52 grams of my hydrogen sulfide. And the problem is asking how many grams of the hydrogen chloride I'm going to make. So it's a limiting reactant problem, right? It's already balanced for me. It's a limiting reactant problem. So here I'm seeing if I use up every drop of my iron 3 chloride, and you can see this is the molar mass, now this is the mole ratio, and then I'm converting to grams. This must be the molar mass of hydrogen chloride. I'm going to get this much hydrogen chloride left. Then I have to do the other reactant to see which one is going to be less. So this is grams of hydrogen sulfide converted to moles. Here's my mole ratio, a different mole ratio obviously because I'm doing a different a comparison. Convert back to grams of hydrogen chloride, and so when I compare the amount of hydrogen chloride I would make if I used up every drop of hydrogen sulfide, it would be 111 grams. If I used up every drop of my iron 3 chloride, I'm going to make 60 grams. So obviously I'm going to run out of the iron 3 chloride. So this is my limiting reactant. That means the hydrogen sulfide is my excess reactant. So I know that I have 90 grams of my iron 3 chloride, and this is just a little bit different way to do this problem. What this is doing now is this is saying, well, I know this is my limiting reactant, and so this is doing a mole ratio that is going to look at the amount of this compared to this. In other words, how much am I actually going to use? I know I'm going to run out of that. And so this is just a little bit different way to do that problem. So I convert to moles of iron 3 chloride, and then I'm using a mole ratio between the iron 3 chloride and the hydrogen sulfide to show how much I'm actually going to react with it. This is the molar mass of hydrogen sulfide. So this is another way that you can find the amount of the excess reactant that's reacted. In other words, that's used up. It's both the same amount of work, so it doesn't matter which one you use. So then you take the 52 grams of hydrogen sulfide that you started with, subtracted from the grams of the hydrogen sulfide that you used up. I'm not sure why. I think this is a typo. This should be 28.4 grams. And then whatever that excess is, then whatever that subtraction is, then you should have that as your excess. And that's how you do a problem with excess reactants.